Good morning. Good morning, class. I wish all of you are okay, and if that is the case, then we can go on with our class today. We are just going to have a quick review on what we looked at under magnetism last week. Then later on, go on to what we are supposed to look at today. And under the review, we looked at what a magnet is. We looked at the different types of the magnet. We looked at the laws of the magnet. We looked at how to magnetize and how to demagnetize. And simply, if I'm to go back, a magnet is a piece that can attract other magnetic materials. Among the magnetic materials, we have iron, we have cobalt and nickel, and then we have steel and other many, but those are the most common ones. We can as well we as well looked at the laws of magnetism, and we say likes do repel and then unlikes do attract. If you have like poles being brought together, they'll repel each other, and then if you have unlike poles being brought together, they'll repel each other. And then we looked at the different types of magnets. We looked at the bar magnet, the horseshoe magnet, the circle magnet, and then the U-shaped magnets. And for all these types of magnets, we saw that it was evident that all of them had north and the south pole. So it is the commonest thing in magnets. They will always have the north and the south poles. And when we come to the magnetizing methods and demagnetizing methods, to magnetize is to make a piece of metal, which is a magnetic material, become a magnet. There are different ways of doing this. You can either stroke it with a magnet, you get a permanent magnet and stroke that piece slowly in the same direction. You have all the dipoles that are aligned in that same direction, and in the end you create the north and south poles, which are the important things for a magnet. And once that is done, you have a magnet. You can as well connect it to electricity using DC as the source, and since DC flows in one direction, it will align the dipoles in the same direction and create a magnet. We can as well demagnetize an already magnetized piece by you can simply heat it, put it on fire. When you put it on fire, it will disorganize the way the dipoles are aligned, and once this is done, you've demagnetized it. Or you can heat it with a hammer such that you disorganize or distort the way the dipoles inside this are arranged. Then in doing so, you will be disorganizing them, and then in the end, removing the magnetism. You can as well connect it electrically to AC, alternating current. The current which does not flow in one direction, you have it move back and forth at a higher frequency, and as does that back and forth, it will be disorganizing the dipoles, thereby demagnetizing it. And having looked at that, we looked at how to store a magnet. Like magnetism can be lost over time if the magnet is not well kept. And for you to store your magnet and it retains its magnetism, you need magnetic keepers. These are simply materials which you put at the ends of a magnet to keep it in safe position. Like, let me say this is my magnet with a north and south pole. If I bring my magnetic keeper and put it next to them, it will be aligned in such a way that there is a south pole here and a north pole here. By virtue of having opposite poles next to each other, we'll have attraction, and the dipoles inside here will remain in the same state, like they will be forced to remain in their normal position. So this keeper helps position or protect the dipoles such that they are in one position, and when they are in the same position as they were and they can't be distorted, they retain their magnetism as far as the keeper is still holding them. Then the last thing that we are going to talk about is the magnetic field, and this is our thing for today. Magnetic field is simply a region around a magnet where magnetic force is experienced. Like, if you have magnet like this, north and south, the region around here and there where the magnetic force is experienced, what we call like if this is north and south, where we have those forces of attraction is the magnetic field. And if this is south and south, where we have those forces of attraction, region around a magnet where magnetic forces are experienced. And since we can't see them, but we can feel them, we can represent them in science using magnetic field lines. These field lines are imaginary, like you can't see them anywhere, but I can feel it in my hand that there is repulsion. So they are imaginary lines that show the strength and then direction of magnetic force. Force being a vector quantity, we need to look at its strength and then its direction. So they show or visualize the strength and direction of the magnetic force. And these have got properties like they'll never touch, they don't meet, they run from north to south poles, and there are many other poles. I've said there are many other poles, and then there's a question here, why? Why are there many other poles? From what I've said, you've got to be able to answer that. So that is a question I expect all of you to answer. Why do we have many magnetic field lines at the poles? That is your question number 1 for that day. And then they are always in a state of tension. It's hard for you to draw them like this, like that. You always do that because if there is a north pole, there is a south pole there. There is a force holding them like this. They are being held in tension. And then if we come to represent them using magnets, using the laws of magnets, if we have two like poles next to each other, we expect repulsion, so the lines are going to repel each other. They are not going to meet. And once they do that, they create a region in between them which we call a neutral point. And this neutral point, like I've said here, it is a point where the resultant magnetic force is 0. In other words, there is no magnetic force. And if we are having opposite poles next to each other, we expect attraction, so we'll have them run from one magnet to the other magnet. And that being said, as your assignment for today, you're going to have page 183 in your blue folders and page 186. This assignment is for 2 days, so I expect to have it on Thursday. Nice time. It's in your blue folders. Be sure to do it. It covers everything we've looked at. A nice time.